So the answer to question 6 is D, 0.0046 molar per second. As usual, what I suggest you do is pause this video, try to solve for that answer, and if you aren't able to find that answer, just unpause the video and work through it with me. So let's go through the question. The decomposition of A has a half-life of 45 seconds. So the decomposition of A means that we are going from A to products and a half-life, so T1 half is 45 seconds. The initial concentration of A is 0.30 molar. So the way to write the initial concentration of A is to put A in brackets and put this not sign here. This is a first order reaction, and it's asking what is the initial rate of the reaction. So let's first start out by writing the rate of the reaction. Well, we know it's first order, and we know that there's only one reactant that is being decomposed. So the rate law is rate equals K times A to the first. First because it's first order, and we only have A in brackets because A is our only reactant. Alright, so let's plug in what we know for now. Well, we need to know what is the initial rate, so we know this is what we're going to be solving for. We haven't been given K directly yet, so that's also going to stay as a variable, but we do know what A naught is. So let's just plug in A naught. And the reason we can use A naught, even though this is only A, is because it's asking what is the initial rate. So really, it's the initial concentration and the initial rate. Now we have to see if we can find K. So the only information that we've been given to find K is that T1 half is 45 seconds. Now this is just something you need to memorize, but in a first order reaction, T1 half is equal to 0.693 over K. This is not the same as a second or 0th order reaction, so this is something that only applies to a first order reaction. So we were told that T1 half is 45 seconds, so now let's just switch this equation around and solve for K. Multiply K to this side of the equation, divide by 45, and don't forget about our units. So solving for K, we find we have 0.693 divided by 45 seconds gives us 0.0154 over seconds for K. So let's plug that into our rate law. Rate equals 0.0154 over seconds times 0.30 molar to the first. So in order to find our answer, which is an initial rate, we're just going to multiply these two together. And we get an answer of 0.00462 molar over seconds. And the smallest amount of significant figures we were given in this problem is 2, which you can see here. So we are going to simplify this to 0.0046 molar per seconds. And that is our answer. It matches the one that we were given, and I hope this was helpful.